strip in half like this. Okay? Take it again and fold it in half again. Okay? So it ends up looking like this, kind of like an accordion when you pull it out. Upside down. Oh, what's going to happen? Okay, the water's all going to come out, correct? We agree on that. Okay. What do you think would happen if I just put this piece of paper on it and turn it over? What's going to happen?
It's going to seep through.
It'll start to seep through. The water will pour through the paper. Okay. All right. So let's try and see what happens when I do that. I'm just putting this paper on top of this. I'm going to turn it over. So. Whoa. What happened? Is that what you expected to happen?
Oh, the pressure was more so it like stuck to it.
Okay, so hold on a second. Think for a minute, everybody. Does anybody know how to spell ozone? Very good. Ozone actually has a chemical formula that looks like this.
There's an ozone.
Just like H2O has a formula like this. Here's the formula for ozone. Okay? So, what's really important about ozone, and we have lots of ozone.
Okay, Lauren, you're going to hold that and break the match.
Good job, Michelle. Do you need me to help put it on? You're doing a good job. Wonderful. You're doing it by yourself. That's great. All right, so just put it right in to extinguish it. Good. Oh, yeah, we fill this up today.
Yeah, I didn't even do the whole thing again.
The bottom one?
Okay, so here's your average number.
So that would be the
Okay,
top.
that would be the top. Look at your formula. Divided by the total volume right there.
And that's what you do?
Multiplied by 100, and that gives you your percent of oxygen. So let's do it. All right.
Oh, there's too much.
Guys, you are working on page 59 while I'm coming around. Please have out your lesson one available when I come to check. And keep working.
Oh my gosh.
Darwin's most famous thing. His theory of evolution is based on natural selection. So what exactly is natural selection? Here's the formal definition. It's the process. What to do is this. There are two questions that I want you to answer. And you're going to answer them on your page. You can see how I did it right here. Okay, questions 1 and 2. I want you to answer those questions. All right? We have a few minutes right now in class where you guys can go ahead and get started on that. You've got the pencils on your tables, colored pencils, so I want you to remember. Yeah. Make sure that you don't bring the test tube above the water level or you'll have to start over again.
Don't distract him. Alan, Jonathan. Jonathan,
8, 9, 10.
Be careful.
11.
Oh no.
12.
Oh, it's
12. Sorry. Okay. And do we have another competitor?
We have 3 minutes. Good luck.
Sophie can go first.
Oh, Rachel.
All right.
17.
I'll be the last. Are you serious?
Okay, Sophie.
Okay, so our word is element, and an element is a pure substance that cannot be separated into any other substances. An example of the element is copper, and it's used for copper wiring in your house for electricity. And then another example is aluminum. You can use it for like foil. And then this is sulfur, and this is magnesium.
And I have 300 milliliters of oxygen. I combine both of those gases in a synthesis reaction, igniting. What am I going to have? What gas am I going to have left over?
Oxygen.
I'm going to have oxygen gas. Give me some examples of characteristic properties. How are they different by characteristic properties? Simran.
Well, the flammability.
Okay, flammability. We absolutely saw a difference there between oxygen, hydrogen, and certainly water. What else, Priya?
Boiling point is higher for the oxygen and
Okay, so there's going to be differences in boiling point. Remember, you should have twice as much of this. And how many of these do you need? 20. Say 20. Now, you're going to have an excess of oxygen by what? You're going to take your data and you're going to plot it. So here's just my suggestion. But you need to look at your own data. Maybe your size variation in your population was different than what I have up here. So you need to look at your own data. Not only that, but then you need to...
0 to 8.
Okay, so you had and 15 to 16? Okay, you had a lot of variation in here. What about this table over here? Which size in this group here had the most number of... What's another word? That we can use in our conclusion. Beans needs to be there.
How to balance the chemical equations in 3 easy steps. If you follow these steps, I'm sure you'll be able to find it really easy and a lot of fun to balance chemical equations. Let's take step number 1. In this step, you need to list all of the elements